Hi guys, I welcome you all to the 11th video of Model 5. And here we're going to define some of the functions that's going to basically help us get the value of the predicted output and then calculates the cost based on that. And let's see how we can exactly build this, and we are also going to make sure that everything is working fine by quick check with all the kind of tests that we can have while after creating this kind of functions. So let's get started. And now is the time to go ahead and code for the forward propagation equations. And I'll be simply going ahead and coding two different functions, one for the prediction part and one for calculating the cost. Now you might be wondering that, what is this forward propagation? Well, you should actually ask what is also this backward propagation over here. Well, both of these propagations are the terminologies that we use highly when we talk about neural networks in deep learning. But yes, because the same kind of ideologies are getting applied over here also, it is nothing wrong to use this kind of terminologies over here as well. So essentially what is happening in the forward propagation based on the current values of the weights and bias. Currently the M over here is nothing but your weight, which we have set to 0. And this C is your bias value, which we have set to 0 as well, right? So based on the current value of your weight and bias, what is your output? And then based on this output, you're going to compare it with the actual values with the help of this cost function. And this cost is simply going to be high if this predicted outputs are not close to the actual outputs. And if this predicted outputs are actually close to this true outputs, this cost function will be less. So in the forward propagation, we get an idea that based on the current values of W and B, if this cost is high or not. If it's high, you still need to update these values of W and B because they are not yet optimal. And if this mean square error is very small, or any type of cost function that you might be using, if it is very small, very close to 0, you can say, in that case, you can say that now this is very close to the optimal values. And how do you know if it's the optimal or not? Then for that, you will require at least two cost functions, which you need to check if it's converging or not. You can also check last 3 values or maybe last 4 values, whatever suits you the best. But yes, in our use case, we'll be comparing the last 2 cost functions and see that if it's converging or not, correct to 13 decimal places. Some of the things won't make sense to you as of now, but will definitely make sense to you once you start coding. But in the forward propagation, we are just checking if this W and B value is optimal or not with the help of cost function. And if it is not optimal, you go to the backward propagation. In the backward propagation, the updation of your model parameter happens over here. So if your W and B are not giving you optimal results, you update it with whatever optimal or optimization algorithm you want to use. In our use case, we are using gradient descent, as you know. But yes, this is what happens in the backward propagation. From the forward propagation, you get this idea if W and B are optimal. If not, you go to the backward propagation and update the model parameters. After updating it, again you do the same process. You check if the outputs are optimal or not. If the outputs are really good, the cost will be less, and lesser the cost, and if it's converging, you say that the training can be stopped over here. So I hope that this whole idea of this training is clear in your head, that why do we call this as a forward propagation and what happens exactly in the backward propagation. But don't really get scared by this kind of terminology, guys. But yes, now it's time to go ahead and code for these two type of functions, so that once we are doing the training process, we don't have to write this kind of codes again and again. Rather, one line of code for each and every step will be done for us very easily with the help of these functions. So over here, I'm having my first function over here for the prediction, where it takes the input array of the whole X train or maybe X test, whatever it is. I'll just say that this X is nothing but the full X data. Let it be train or test, whatever it is. Then this W is your weight value. B is the bias value. It's not an array, it's just a simple value. That's what we are saying. So full X array data, let me just call it that to make it a bit more clear. And you can just change this kind of descriptions the way you want. And it's going to return what? It's going to return the predicted output, which is actually the weight times X plus B. So I'm just going to say that it's going to return, I'm going to ignore this pass. I'm going to say that it's going to return what? X times W plus B. The inputs are getting multiplied with one value, that is of weight, and then we are adding the bias value on top of that. So this is your prediction function ready. And you can also just run this code and check if it's working fine. I can just call this predict functionality over here and pass in my X train data as the input. And W and B value are already preset over here because we have said that W and B are 0. And now we can go ahead and simply run this code and the outputs will all be 0. Yes, that's true. Why is this the case? Because in the prediction, when the W and B both are 0, the outputs are 0. Now, if you can check, let me just save it in the ypred. Let's say ypred dummy. All right. And let me print the length of the ypred dummy. How many outputs are there? And if you can guess it correctly, there will be 100 different values. Why? Because there are 100 different values in the X train. I hope you remember this from this particular part. We had created 100 different values for your X train. And respectively, you will also have 100 values in your Y train. You can also check it by printing the length of your actual Y value. So what is your length of Y train? Let's check that. It should be also 100. If not, there is some problem. And because it is 100, everything is good. So I can just get rid of everything and just give you the output of this prediction, and also can write a comment over here. Check the predict function. If it's working fine, you are going to get this kind of an output. All right. And that too only if you're using the W and B value to be 0. If in your case you have chosen some different random value of W and B, then surely you will have some different values over here. But there is no problem with that if you have started getting some outputs and if you are following this kind of procedure. All right. Now, after this, the second type of function we need to code is the cost function, where the first 3 inputs are just the same from the top part. So if I want, I can simply copy this part over here and paste it over here. And the Y is the target values, which is nothing but like, I can just call it as, it's not always the Y train. It can also be Y test. I'll say that full Y array data. Okay, again, it can be used for train and test purpose. And it's going to return us what? It's going to return us the mean squared error. Now, what is this mean squared error? It is the difference of the Y and Y prediction, or you can call it as an error. It's the squared of an error whose mean we are going to take. So if there are 100 rows, this squared error is going to be calculated for the 100 different times. You simply add them together, all the squared errors, and then divide it by the total number of rows, that is 100 in this case. And that will be the mean squared error. So let's see that how we can code for this. It's very simple, guys. First of all, I'll just say that I want to return what? I want to return MSE. Now, what is this MSE? Let's figure that out. First of all, I need to have squared error. So my squared error is what? It's actually this Y data that I'm passing in minus the Y prediction. So now what is this Y prediction? Let me calculate that. My Y prediction is what? It is actually the predict function that we have created above with the same inputs that we have given over here. This X is the same X that we are passing over here. So that's the same X. Again, the same value of W and same value of B. So this is going to give us the Y prediction. After this, I'm going to square the error, which is nothing but Y minus Y prediction, and then square of it. And then I just take a mean of this squared error. That is your MSE, which is what? np.mean. NP is giving you this functionality of calculating the mean, which is same as actually summing all the values of the squared error and then divided by 100. In this case, 100 because we are having 100 rows of data. Or else you can simply use np.mean of squared error. And that's it. You can simply go ahead and return this part only. You don't even need to do one extra line of code over here. I'll just delete this whole line and say that I want to return this part. And now I can run this code. And I guess there's a problem over here because this is squared error, not square error. Yes, everything is fine now. We can check if it's working over here or not. So over here, I'll say that cost function, what all things is it taking as the input? I'll have to copy paste that part. I'll just copy this whole thing and pass it over here. And I'll also write a comment check for the cost function if it's working fine or not. If it's working fine, we are going to get one output. It's saying that X is not defined because instead of X, we need to pass in X train. Instead of Y, we need to pass Y train. And now we are having this 155.647 as the cost function. when the W and B values are 0. And because we got this value, it means that your cost function is working fine. Again, if your values of W and B are different, you might have a different value, so don't worry about that. The final thing that you are going to check is that at the end of the training, this value of W must be very close to 2 and the value of B should be somewhere around 9.5ish kind of value. That's the thing that you must get. If that's not the thing you are getting, it means there is some kind of a problem in your code. So yes, this video was focusing more on how you can create this kind of functions for yourself in order to predict the output based on the inputs that it's going to receive. And then based on that output and the actual value, what is the cost function? We are going to repeat this for the whole data. And that's exactly how we find this cost function. Now in the next video, we are going to define some of the functions for the backward propagation, where we can basically use the gradient descent to update this kind of model parameters.